We usually trace the origins of mechanical humans through a timeline that begins and ends in the West. Standard histories point to the automata of Greek mythology or the detailed engineering notebooks of the European Renaissance. These records often overlook the Indian subcontinent, leaving a significant gap in the global history of robotics. However, a technical manual from 11th century India suggests that the conceptualization of artificial life was already well documented elsewhere. Between 1000 and 1055 AD, King Bhoja ruled central India under the Paramara dynasty. Bhoja authored the Samarangana Sutradhara, an encyclopedic work. Chapter 31, titled Yantra Vidanam, translates to the rules of machines. This chapter includes a detailed section on the Stri Purush Pratima Yantra, or male and female statue machines. King Bhoja's instructions describe functional engineering, detailing a mechanical system designed to perform the tasks of household servants. Read from the perspective of a modern engineer, the text reveals a sophisticated understanding of mechanical physics. The exterior chassis was built from wood and covered in leather to simulate a human appearance. The movement relied on an internal network of iron wires and strings routed through the frame. These iron tendons were adjusted over smooth, greased pegs. By manipulating the tension, the operator triggered specific movements in the neck, hands, and fingers. These 11th century designs demonstrate a grasp of how to translate linear mechanical pull into human-like kinetic movement. The Samarangana Sutradhara describes these machines performing basic domestic labor, such as pouring water, offering betel nut, or bowing to welcome guests. Complexity increased with the use of rhythmic timing and gears, which allowed the wooden figures to play stringed instruments like the veena. The text eventually moves past domestic use into the realm of physical security. It describes placing these wooden figures at doorways and arming them with maces or spears. These sentinels were intended to act as mechanical deterrents, striking at intruders who attempted to enter a home under the cover of night. This progression from service-oriented tasks to defensive applications follows a similar logic to the development of modern autonomous systems. This level of mechanical complexity raises a question about power. Without electricity, how were these systems actually driven? The authors of the text made a deliberate choice to omit the specific propulsion mechanism from the record. Translators suggest this was a safety protocol. The engineers kept the power source secret to prevent the machines from being easily replicated or misused by others. These ancient developers treated their core propulsion method like modern proprietary code, shielding it to manage the technology's impact. India currently stands as a major hub for the production and export of modern robotics. Sustained growth in this sector depends on the nation integrating its future ambitions with its own scientific history. Recognizing texts like King Bhoja's validates the fact that a rigorous, analytical approach to machinery was present in India 1,000 years ago. The conceptual roots of artificial creation have existed in the Indian